In this video, I want to review all of the rules for derivatives that one might encounter in a Calculus 1 type class. I've been getting a lot of questions in my tutoring sessions about when to use each rule, power rule, product rule, quotient, and chain rule, and when to use a combination of the rules. So I'm going to go through all four of these first, and then we might tackle one with a combination of some of these rules at the end. So let's jump into one with the power rule. So let's suppose that f of x is equal to x cubed plus 6x squared plus 4x plus 8. And we are asked to find f prime of x, which is just the derivative of f of x with regards to our variable x. So I went ahead and wrote the power rule down here in red. So if we have a function that is made up of polynomial components, that is x to a power of n, then the derivative of f of x is equal to n times x to the n minus 1. So f prime of x in this case is equal to 3x squared. That's by bringing the n down here, but our n is 3 in this first case. So we'll have 3 times x to the n minus 1, n being 3, so 3 minus 1 is 2. Same thing here, we'll have 6x squared. X squared is our f of x here. We bring the 2 down, that's here, and then x to the n minus 1, that's 2 minus 1, so we'll end up with 12 times x, because 6 times 2 is 12. And then the same thing here, this is x to the 1, so we bring down a 1, so we get 1 times x to the 1 minus 1, but that's just 1, so we have plus 4 here. And then 8 goes to 0 because the derivative of all constants goes to 0. So this is a good example of where you would use the power rule when you have functions that are made up of polynomial components where you have x to a certain power, like x cubed, x squared, or any greater powers, or less powers than that. You could do this for x to the minus 2, in which case you would get negative 2x to the minus 3. You bring this minus 2 down, and then you subtract 1 from minus 2, giving you x to the negative 3. Okay, so we checked this box. Let's move on to the product rule. Okay, so I wrote the product rule down here in orange. And that tells us if we have a function that's made up of two functions multiplied together, we'll call those g of x and h of x. Then the derivative of the overall function is the derivative of g of x times h of x plus g of x times the derivative of h of x. So in this case, we'll say that our first function x squared is g of x in this case, and our second function, sine of x, is our h of x. So that means when we're looking for f prime of x, we take the derivative of g of x first. The derivative of x squared, as we just saw, is 2 times x by the power rule. And then we leave h of x the same. So this is going to be 2x times sine of x. And then we need to add regular g of x, so that's x squared, times the derivative of h of x. So the derivative of sine of x is cosine of x. So we are left with this sum here, 2 times x times sine of x, plus x squared times cosine of x. And this is our whole derivative for f of x in this case. And before we move on, I'm just going to box each term in a color and then outline which part of our rule this is. So this 2x right here is our g prime of x, because it's our derivative of x squared. And then sine of x is h of x. And these two are multiplied together. G prime of x and h of x are multiplied together. And then g of x is right here, and it's multiplied to h prime of x, which is cosine x. So I just wanted to point those out before we moved on, but this is our final derivative boxed in purple. Okay, so we're done with the product rule. Let's move on to the quotient rule. Okay, so here in green I have written down the quotient rule, which says that if f of x is comprised of two functions, one on the top and one on the bottom of this division sign right here, then the derivative of the total function f of x is equal to g prime of x times h of x minus g of x times h prime of x all over h of x squared. So let's go ahead and take a look at an example. We'll use, in this case, x to the fourth plus 3x over x squared plus 6. And if we want to find the derivative of this thing, we can use this quotient rule because we have one function we'll call g of x, this top part, over h of x, this bottom part, x squared plus 6. So first what we want to do is take the derivative of g of x, that's the top. So we're going to take this exponent down and then subtract it by 1, so we have 4x to the third. That's the derivative of this bit right here, plus 3, that's the derivative of the right top part, and that's our g prime of x. So we can put parentheses around this because now we're going to multiply it by h of x, but h of x is just the bottom, so that's x squared plus 6. But now we have to subtract g of x, but that's just the top, so we'll put this in parentheses, x fourth plus 3x, and now we need to multiply the derivative of the bottom, but that's 2x because we move this 2 down and then subtract the exponent by 1, so that's 2x, and then the 6 goes to 0. So we're just left with 2x as our h prime of x here. And then we divide this entire thing by x squared plus 6 all squared like that. But now we can simplify this out a little bit. We can expand out these top two terms. That gives us 4x to the 5th plus 3x squared plus 24x cubed plus 18 minus 2x to the 5th plus 6x squared. And that's all over x squared plus 6 all squared. But now let's finally simplify this a little bit. We can combine some like terms. So this 4x to the 5th minus 2x to the 5th becomes 2x to the 5th. This 3x squared combines with this 6x squared to make 9x squared. After this 24x cubed. And then we add 18. So our final derivative here is 2x to the 5th plus 24x cubed plus 9x squared plus 18 all over x squared plus 6 all squared. So this is our final derivative in this case. This is f prime of x when we start with this function up here. Okay, so now that we've got this quotient rule done, let's move on to the chain rule, and then we'll look at one problem that kind of fuses all of this together. So lastly, we have the chain rule, and that says that if we have a function f of x, that is one function h of x contained within another function that we call g, then f prime of x is equal to g prime of h of x times h prime of x. And I think the best way to describe this is when you have a function that's inside another function. So let's say we have the function f of x equals e to the sine x, where sine x is all in the exponent there. But notice we have sine x plugged in where the x normally would be in a normal function e to the x. So that means our sine here is h of x because it's inside of another function e to the x that we'll call g of x. And the way you really want to think about this is when this h of x is plugged in where this x would be in the purple function or in our g function down here. But now we can follow the formula. We have g prime of h of x. So what we want to do is take the derivative of this purple function and then plug in h of x where we have any x's. So the derivative of e to the x is just e to the x. But then we want to plug in our blue function wherever we have an x. So that gives us e to the sine of x. But that's what we started with. And now we just have to multiply by h prime of x, which is just the derivative of this blue function. In this case, that's cosine x. So our final answer here is just cosine x times e to the sine x. And that is f prime of x in this case. I'm going to do one more problem where I fuse a couple of these rules together. So here I have a function f of x, which is equal to x squared times sine of e to the x. And we're asked to find the derivative of f of x. So first what we want to do is use the product rule of these two functions that I'm going to underline in red and blue. So this red function is x squared, and it's very clearly multiplied to sine of e to the x. But remember, the product rule says that we need to take the derivative of one, multiply it to the regular of the other, and then add them to the derivative of the other times the regular of the first. So we'll have 2x, that's the derivative of the red function, times sine of e to the x, that's the regular blue function, and then we want to add x squared, that's the normal red function, but then we're going to have the derivative of this blue function that I'm just going to leave as a gap that's blue right here because it's going to take a little bit more to solve because the answer isn't immediately clear as to what it's going to be because we have this e to the x inside of sine, which indicates to us that we need to use the chain rule. So to find the derivative of this function, what we need to do, like I said, is use the chain rule, which means we need to take the derivative of the inside, so that's going to be e to the x, because that's what's inside this sign here. And then we need to multiply it to the derivative of the outside with the original plug back in. But the derivative of sine of x is cosine of x. But then we replace x with e to the x because we're plugging this function back in all the places that we have x. So this is the derivative of our blue function up here, which means we can put this in for our blue gap right here. And now by using the product rule and the chain rule, we have our total derivative for f of x. And that's enough for now.